ETH0:1, the name of the interface. Then 2, modify ifconfig ETH0:1 to reflect aliased IP address. Another note, aliases do not work with DHCP interfaces for obvious reasons. When you define an alias, you know exactly what IP addresses you intend to assign to that Ethernet interface. So keep that in mind. So that's a little bit about how interfaces are brought up in the environment. Again, in the network-scripts directory where you find ifconfig-eth0, there are other items. For each type of interface that's defined on your system, if up, when the network service is invoked, will bring that interface up, such as loopback, ETH0, and ETH0:1. Additionally, IPv6 support will be set up if it's enabled. But there's support within the Linux environment, within the kernel and via modules, for other types of protocols, such as PPP, used for dial-up access, which is more and more becoming outdated, IPsec, for setting up VPNs, IPv6, for routes, for downing and upping routes, and other protocols, such as SIT, parallel IP, and that's parallel line IP, networking over a USB interface. There's even a script to detect hot plugging, in particular for laptops, where you may eject or insert a PCMCIe card at will. So there's scripts for everything, and if the kernel detects the interface type, or if you use the networking tool to define that type of interface, an entry will be created. Again, just launch system config network. This brings up the GUI, and from the GUI you can add various interface types using new, for example, which brings up a wizard, which we've yet to show you. The default or first option is to define an Ethernet interface, for which you'll have to select a card or a different Ethernet card, and if you have a driver, you can supply that. And there are other types of connections, ISDN, modem, which will allow support using a PPP interface, token ring, not as common so much nowadays, but you can define it based on a card that may be in your system if Linux has detected it. A wireless connection, again, if you have a wireless card and Linux has detected it, then you can provide wireless support. Otherwise, you'll have to get a driver for the card, as well as a DSL connection. It supports XDSL, that is the Linux kernel, so ADSL, SDSL, etc. All supported by the kernel if you have the appropriate drivers and support for the hardware. It also supports PPPoE. Notice this time when we launched system config network, the alias interface was brought up because of the file that we created. So had we defined an alias interface using the wizard, it would have done the reverse, which is to create a file. And if you double click on this Ethernet interface, you'll see its nickname is :1 with similar settings. So you can define aliases from the GUI tool as well. Just navigate through, bind it to the lone card, give it an address such as 192.168.75.12, the next IP up, set a subnet mask that's sensible, an optional default gateway. By optional, we mean just that. Otherwise, the interface will default to the default gateway. And then this will set it to ETH01 as the next one, or if we want, we can indicate a nickname to set it to ETH02, or cancel altogether. By default, the GUI attempts to use the next logical device. So if we click on apply, it will make a new device, ETH0:1, which conflicts with our previous device. So now you need to determine which one's legit and up it or down it. Let's remove our old device. We'll just get rid of it altogether. And as for the profile, we don't want to delete the whole profile. We'll get rid of ETH0:1, the old one that we defined, close the box, and then examine the contents of network-scripts where we see ifconfig. We should have a cat in our history here somewhere for the new instance. And this instance, as you can see, is .12 with user control set to no, which means you must be root to make changes. So again, That's a little bit about how it brings up the interfaces. That's the kernel in conjunction with the network service, which references, again, etc sysconfig network to determine if support should be provided, and if so, then it navigates into the network-scripts directory and looks for different files to incorporate into the if-up process, brings up those interfaces, and makes them available on your system. So now we have ETH0, ETH02. You can remove this interface as well. If you no longer have a need for it using ifconfig, we should just point that out. ETH0:2 delete, for example, followed by the IP address of the interface, which we listed, let's just ifconfig again, as 10.168.76.11, and optionally by specifying the net mask, but this will remove the interface, the virtual interface or sub-interface. Now we've got only ETH0 and loopback adapter. Let's just note that as well. Ifconfig ETH0:2 delete followed by the IP address that we had assigned to the interface removes the virtual interface. So you know how to add IP addresses, how to configure interface. This configuration is generally performed during installation, but if you need to provide additional configuration once the system's up and running, supposing you've inserted a new network card or just want to nail this interface, then launch the system configuration tool for networking. We did mention that the system configuration tool for networking is available as a text user interface as well. Execute system config network dash and just tab it out to get the TUI interface, text user interface. This brings up a text equivalent which reads the scripts in network-scripts and allows you the flexibility to modify the interfaces or to define a new device altogether. If you press enter on one of the devices, you'll see the properties of the device plus the ability to make the interface DHCP. Once your changes have been committed, the text files will be updated. If you need to define a new device, just navigate to it and press enter, and you get the ability to define Ethernet, modem, and ISDN devices. Enter on add, define your interface, and shortly you'll have an ACE interface up and running, unless you point it to a different physical interface. Again, all of these items are referenced from the sysconfig and below directories, such as network scripts. The network service, when it starts, reads the items in the network-scripts directory, such as ifconfig ETH0, ETH0:1, routes-ETH0 or routes-ETH1 to know how to set up routing, for example, for those interfaces. Now, as far as IPv6 configuration is concerned, if you execute an ifconfig, plain old ifconfig, in addition to IPv4, you see IPv6 configuration information. In fact, we have two IPv6 addresses defined. FE80, and we'll just indicate using : let's just set up a brief section here, IPv6 config, and we'll list first and foremost as the important feature, it's auto-configured by default gateway, which is usually your router. That's first and foremost. Second, whenever you see an FE80 address, this is a link local address, which is the loopback address. But in addition to being loopback, it can also be used on the local subnet. So it's a loopback/local subnet address. And it's like the automatic IP that's configured with IPv4, the 169 address that we saw in our routing table. FE80 can be used to communicate with other folks on your local subnet. And an address is automatically configured based on FE80 and your MAC address. And that's what we see here with this address. We can communicate with this address and communicate with other folks on the wire using this address. In order to communicate, let's say using ping with IPv6 addresses, use ping6. So for example, ping6 interface ETH0 followed by the FE80 address will do the trick. Let's give that a try, and you need to specify the source interface for this local address. We'll just copy it from our interface here without the prefix, the /64, and this pings using IPv6. Also notice that there's a 2002 address that's configured. This address is automatically configured by our default gateway. It is set up for IPv6, that's the router, the Cisco router, and it propagates the prefixes to the DMZ as well as the internal networks. So as a result, during IPv6 configuration, our interface was auto-configured with this 2002 address, which we configured during the recording of IPv6 Linux CBT edition. So ping 6 of this address as well will return useful information. This is a full IPv6 6-to-4 address. So we'll just also note 2002:: is a 6-to-4 address that can be configured based on IPv4 embedded address using hex notation or hex numbers. But again, IPv6 is auto-configured. The subnets and everything are defined on the router on the default gateway, and then the prefix is assigned to the host. The host's MAC address is embedded in the IP version 6 address, whether 6-to-4 or some other address. And you can see it. For example, our interface terminates with 4108. Here we see 4108. And if you go back through the address, you'll see the 02B3 with the embedded FFFE, then 98, then 4108. So IPv6 is auto-configured by default, and there's no need for you to worry about configuring it. In addition to ping 6, you've also got traceroute 6. This is used to trace routes on IPv6 networks, whereas ping 6 is used to ping IPv6 addresses. There is no netstat 6. From the command line, if you simply netstat MTL, you'll see bindings for both IPv6 indicated by the series of colons, as well as a traditional all zeros or an IP version 4 address. So this is an IP version 4 binding. This is an IPv6 binding for SSH. Now that said, we'll continue sprinkling networking throughout the remainder of our studies to shore up and beef up your knowledge on IPv6, IPv4 configuration and implementation within a Red Hat Enterprise environment.